going to go over quadratic equations. Now, we just went over quadratic functions last lecture. And the whole purpose of what we did last lecture was to put it in a solvable form, essentially, by completing the square. Now, we're going to start with a pretty basic one here today. And then we're going to convert back into what we were doing with the completing the square so that we can actually do a solve step based on that. But in order to get started, we have to review the zero product property, which says if a product of two or more factors equals 0, then at least one of the factors must be 0. Because A times B equals 0 means that either A has to be 0, B has to be 0, or both of them have to be 0. Now, let's look at the equation 3x squared plus 10x minus 8 equals 0. We want to solve this by factoring. Now, there are many methods of factoring. I'm going to show you factoring by grouping because that's what you should have learned in Math 108 if you took it here at USCA. And in order to factor by grouping, we need to look at our AC and our B, right? Remember, this is the A, this is the B, and this is the C. Now, AC, so A times C, is 3 times negative 8, which gives us negative 24. Our B is 10. So we basically now need two factors of negative 24 that add to 10. So what if we broke negative 24 down into a positive 12 and a negative 2? Okay. So how does this look? Well, it looks like 3x squared plus 12x minus 2x minus 8 equals 0. And it honestly doesn't matter the order you put these in. You could have put negative 2x first, or you could have put 12x first. It still winds up being the same thing once you factor it out. Now, I'm going to factor by grouping here, which means I'm going to group the first two terms together, and then I'm going to group the second two terms together. So, in the first two terms, I'm going to pull out a 3x, and that's going to leave me with an x plus 4. And then the second two terms, I'm going to pull out a negative 2. It's going to leave me with an x plus 4. And then I can pull out the x plus 4, and it will leave me with a 3x minus 2. Now this whole thing equals 0. And by the zero product property, we know that if this first term times this second term, since they're multiplied, a times b equals 0, that means that either 4 or x plus 4, oh, that's ugly. Let me rewrite that. I'll even start another color here. That x plus 4 has to equal either 0, or 3x minus 2 has to equal 0, or they both have to equal 0. So let's figure out what x would make x plus 4 to be 0. If I subtract 4 to the right hand side, it looks like x equals negative 4. Gives us a 0 option here. And if I solve for x in this other one, the 3x minus 2, I add 2 to the right hand side. I get 3x equals 2. I divide by 3. I get that x equals 2/3. So, here, we've solved the equation. And we have two answers. X could be negative 4, or x could be 2/3. That's simple. So, we have solved, in this case, by factoring, and we've come up with our two answers. Now, how about the square root method? That's what we'll look at next. Now, if we wind up in a scenario where we have x squared equal to some k, that means that x has to equal either plus or minus that k. Essentially what you would be doing is taking the square root of both sides, right? Which means, that I had an error here. X squared equals, you could either, yeah. So, let's do it like this. I had a typo in this lecture, how about that? So, x squared equals k, then x equals plus or minus the square root of k. Okay. Sometimes the square root function doesn't pick up when I try to type it into PowerPoint. That's probably what happened there. I'll have to go back and fix it. Alright, what this means is that if we generalize this for anything squared, so in this case, if I try to say, well, what about x minus a squared? What if that were to equal a k? Technically, that would mean that x minus a would equal plus or minus the square root of k, right? Which means that x would equal a plus or minus the square root of k. Now, the reason we have to add plus or minus here is because it's a squared term, right? So if I told you that x squared equal 9, right? Now, you would tell me that x equals 3. And I would be like, well, that could be correct because 3 squared is indeed 9. But you could also tell me that x equals negative 3 because negative 3 squared also equals 9 because a negative times a negative is a positive, right? And that's why we have to take into account both the positive and negative aspects here. Now, let's put this in a full equation form and try to solve. Here we have 3 times x minus 2 squared plus 1 equals 0. All right, first thing I'm going to do is solve it down to where I basically just have this squared term by itself on the left-hand side and everything else is moved over to the right. First thing I'm going to do is subtract 1 to make that happen. That'll give me 3 times x minus 2 squared equals negative 1. And then I can divide this left-hand side by 3 and the right-hand side by 3. And it's going to give me x minus 2 squared equals negative 1/3. All right? Now, here's the deal, right? At this point, what I need to do is I'm able to now take the square root of the left-hand side and basically show that it's plus or minus the square root of the right-hand side, right? So here, this x minus 2 would equal plus or minus the square root of negative 1/3. Following me? Now, we have dealt with negative square roots at this point, right? That's the only reason I don't hesitate here, is because we know how to handle a negative square root. It's when the I term comes into effect, correct? So, technically, this is x minus 2 equals plus or minus I square root 1/3. All right? And these parentheses are over here on the left-hand side still, but they don't really hold much here. So I can add 2 over to the right-hand side to just solve for x. So that x equals 2 plus or minus I square root 1/3. Fair enough. Easy enough, right? Now this is 2 solutions here. This is the solution 2 plus I square root 1/3. And this is 2 minus I square root 1/3. Right? Easy enough. Alright? Now, what if we want to try to solve by completing the square? Well, what we're going to first do is convert the standard form of the quadratic equation to a vertex form like we did last lecture. And then we'll solve using that square root method because we'll wind up having something squared on the inside like we did in the last example. Okay. So let's look at 3x squared plus 10x minus 8. Let's try to complete the square on this one. Okay. Now following what we know about completing the square, right? If I look at this piece right here, I want to pull the a out. It's going to leave me with an x squared plus 10 over 3x. And then you can leave this minus 8 equals 0 here, right? Now, I need to complete the square of this inside part. Ooh, this looks like it might be a little difficult. So, this is x squared plus 10/3 x. Remember this 10/3 here? That's technically our n, right? Right? And if we want to find this term that we need to add on to complete the square, we need to look at n squared over 4. All right, so that's 10/3 squared over 4. Now, 10 squared is 100, 3 squared is 9, and all of that's over 4. Or you could even write it as a 4 over 1. Benefit of that is that it would be 100 over 9 times 4 over 1. Keep the top, change the sign, flip the second one. Now you're looking at 10 divided by 4. That's 25. So this really does kind of simplify to 25 over 9. Okay, easy enough. All right, now remember we can't just add that all willy-nilly. If we add it, we also have to subtract it. Now we can take this piece and put it in for this one. Okay, but before we can do that, what we want to do is actually go ahead and complete the square on the inside part of this so that it actually looks like something squared. So in this case, that's going to wind up being x plus, remember it's just the n divided by 2 on this interior part here. N divided by 2 in this case is 10 over 3 divided by 2, which is just 5/3. So, if you can always double check yourself. 5/3 plus 5/3 is 10/3. 5/3 squared is 25 over 9. So this is indeed equal to this entire thing up here, which can now go in right there. I'm going to take a second here to pause and tell you that I can work these problems a lot faster than what you can probably work them. So I hope that everybody's taking advantage of the pause feature here on the videos to pause it and work it yourself to see where everything's coming from, because I don't want to have a lot of dull empty space here where I'm not saying anything waiting on you to catch up. So please, 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 I know I'm throwing these numbers, especially these fractions, around kind of fast. Pause and try to figure out where they come from. And if you're having trouble, reach out to me. All right, so now we're putting this piece back in here. So it's going to look like 3 times x plus 5/3 squared minus 25/9 minus 8 equals 0. Okay. Now we'll do it just like we did when we completed the square. We'll distribute the 3 to the pieces here. So we're going 3 times x plus 5/3 squared. If I distribute the 3 here, it turns into negative 25 over 3, because the 3/9 reduces to a third. And then on the outside here, we'll have minus 8 equals 0. Okay. Now, I need to combine the negative 25 over 3 and the negative 8. Oof, this one might even be kind of hard for me to do in my head. Take advantage of you have a TI-80 384 that you can use in this class. Take advantage of it, excuse me, to help you with some of the fractions, because it will indeed do all the fractions for you if you know how to input it. I'm going to go over here, use mine instead of putting a big fraction out on this form, and see what I get. So 25/3 and an 8 there should give you 49/3. So if it simplifies down to look something like this, 3 times x plus 5/3 squared minus 49/3, okay, equals 0. Now, the whole deal in this is we're trying to solve. We're not just trying to complete zero. We're trying to solve, and we have an equivalency here with the 0. Now, what I need to do next is I need to go ahead and add that 49/3 over to the right-hand side, right? And then that's going to give me 3 times x plus 5/3 squared equals 49/3. I can then here divide by 3 on both sides, and that's going to give me an x plus 5/3 squared equals 49 over 9. Okay. Now, let's see. Did I give myself an extra slide on this? I did. Okay. So I'm going to take this and put it over on the next slide so that we can work with it a little bit further. So this is going to be x plus 5/3 squared equals 49 over 9. Now, I can take the square root of both sides now because I have a simple squared term all on one side. So that this looks like x plus 5/3. The square root of 49 is 7, and the square root of 9 is 3. So now I have x plus 5/3 equals 7/3, right? But it's also plus or minus. Don't forget that part, right? You have to add in that plus or minus, right? Got just like we did on this one where we had the I, we had a plus or minus. You gotta add in that plus or minus, right? So now what we're gonna do is we're gonna subtract 5/3 over to the right hand side so that we get x equals negative 5/3 plus or minus 7/3. Okay. Now, that is two answers. So I'm going to go ahead and split it into two answers. That is x equals negative 5/3 plus 7/3. And that is x equals negative 5/3 minus 7/3. Okay. Now this one reduces to 2/3. This one looks like, let's see, negative 5 and negative 7 should add to give you negative 12. Negative 12 divided by 3 is 4. So it looks like it gives you 2/3 and, negative 4. And we have solved it by completing the square. Now, if you look back, this is the very same one that we did at the beginning of the lecture here, where we actually solved it by factoring. Negative 4 and x equals 2/3. Negative 4 and x equals 2/3. Right? Alright. Now, I've got another one for us to do, so I'm going to clear this, erase the ink on this slide, and then go to the next one. So here we want to solve this one by completing the square. Try to follow the prompts a little closer on the PowerPoint for this one, but it still works out to be the same thing. We want to convert from the standard form to the standard form of the quadratic to the vertex form here. Here we have x squared plus 4x plus 9. Okay, we're really just looking at this x squared plus 4x part. If we wanted to complete the square on that part, hopefully you see that this is a pretty easy one. Right? The n here, we're looking at n squared over 4, right? The n here is 4, so that's 4 squared over 4, which is really just 4. So I need to add 4 here and subtract 4 here, right? Then I have the plus 9 equals 0. I need to actually factor it here. So that winds up with x plus 2 squared minus 4. And then plus 9 equals 0, right? The good thing here is we don't have an a out front. If we had an a out front, we would have to put a parentheses around this and multiply it by the a, but we don't have that here. So that we can really simplify this down to x plus 2 squared and then plus 5 equals 0. Now we can solve using the square root method fairly easy on this one, right? I'm just going to rewrite it here. We're going to subtract 5 over to the right hand side. This is going to give us x plus 2 squared equals negative 5. This is going to give us x plus 2 equals plus or minus the square root of negative 5, right? Which is going to give us x plus 2 equals plus or minus I square root 5, because I want to get rid of that negative 1. If I subtract the 2 over here, my final answer here is going to be x equals negative 2 plus or minus I square root 5. Just that simple. Now, if you have used the quadratic equation before, you can use the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a will give you the same answer as solving by completing the square or solving by factoring, but I'm just showing you another way at this point. Okay, so let's complete the square on this one. Now this is a little different, right? Because in this one it's not equal to 0, and here it's just equal to a number. But let's go ahead and try to complete the square, because the main part we're going to look at here is this left hand side anyway, the 4 times x squared minus 24x. And you know that equals 15. Let's focus on that left hand side. First thing we're going to do is pull the 4 out. That's going to leave us with an x squared minus 6x. And then of course this equals 15. Now here our n is 6 or negative 6. But we're really just looking at n squared over 4, right? 6 squared is 36 over 4 is 9. Alright, we can deal with that. So this needs to be 4 times x squared minus 6x plus 9 and minus 9 equals 15, to where if we factor it, it's going to look like x, let's see, minus 3 squared, keep that minus 9 on the outside, equals 15. So the x minus 3 squared comes from this piece right here. Minus 3 times minus 3 is 9, minus 3 plus minus 3, negative 6. Alright, now I need to distribute the 4 here. So if I distribute the 4, I get 4 times x minus 3 squared minus 36 equals 15. Clean my handwriting up a little bit. Okay, now we can go about solving for x here. I'm going to add 36 to the right hand side. So I get 4 times x minus 3 squared equals, let's see, 15 plus 36. Let's see what that gives me. 15 plus 36 gives me 51. Okay. Then I'm going to divide by 4. Okay. I can do that. That's x minus 3 squared equals 51 over 4. 12 3/4. Alright, so now we can take the square root of both sides, and we're going to get x minus 3 equals plus or minus the square root of 51 over 4, which you could really write as x minus 3 equals plus or minus the square root of 51 over 2, if you wanted to. 51, I think 3 goes into 51 17 times, but neither of those have a square root that we can really pull out there. Alright, now we can just go and finish solving for the x here. So here x equals 3 plus or minus the square root of 51 all over 2. Okay, because I added 3 to the right hand side. So here's our two solutions. One solution is 3 plus the square root of 51 over 2. The other solution is 3 minus the square root of 51 over 2. Easy enough, easy enough. Okay. We got another one. We got 3x squared plus 12x minus 20. Sure. Okay, same thing here. I'm going to pull out the a. In this case, that's the 3. It's going to give you the x squared plus 4x. Remember that equals negative 20. Now I'm going to try to complete the square for this interior part here. We've seen this one. We have seen this one. I don't even know how far back I have to go to show you that one. But we have seen that one, right? There it is right there. The x squared plus 4x on the interior. We have seen it quite a few times. It should be an easy one for you to complete the square on at this point. Now, it's going to be 3 times x squared plus 4x plus 4 minus 4. If you need to take a second to figure out why that's the case, then go back in the lecture where we've completed the square for x squared plus 4x on the inside like 3 times already. Alright, now we can write that as 3 times x plus 2 squared minus 4 equals negative 20. So this part right here is just this part right here, right? Now we can distribute the 3. So it gives us 3 times x plus 2 squared. And then 3 times negative 4 is negative 12 equals negative 20. Okay. Now, at this point, I'm going to add the 12 over, and it's going to give us 3 times x plus 2 squared equals negative 8. Okay. I'm going to divide by 3. So it's going to give me x plus 2 squared equals negative 8 thirds. Okay. And then I could take the square root of both sides. It's going to give me x plus 2 equals plus or minus the square root of negative 8 thirds. Okay. Now, we change colors here and do a little aside. Let's look at the square root of negative 8 thirds. Okay. Now, obviously I need to pull the I out. Clear and easy to see that. But let's look at the square root of 8 thirds. Now, 8 can be comprised of 4 and 2. 3 I really can't do much with at this point. Square root of 4 is 2, right? So if I broke it up like this, it would be 2i square root 2, and then I would have the square root of 3 in the denominator, right? Well, if I didn't want that square root in the denominator, I could rationalize the denominator by multiplying by the square root of 3 over the square root of 3. Okay. Now that gives us 2i times the square root of 2 times the square root of 3 all over 3, because the square root of 3 times the square root of 3 is 3, right? And this could simplify down to 2i times the square root. 2 times 3 is 6 all over 3. If you wanted to rationalize your denominator, if you had a need to. Okay? All right, so I'm going to come down here. I'm going to say, okay, this is x plus 2 equals plus or minus 2i square root 6 over 3. Okay? Everybody hopefully can see where I got that from. Now all that's left to do is subtract 2 over to the right-hand side, and I have it solved out. I have x equals negative 2 plus or minus 2i square root 6 over 3. And there it is. Sometimes they want you to rationalize it, the denominator. Sometimes they don't really care. But there's a short example to show you how to rationalize if you need to. And rationalize is just talking about getting the square root out of the denominator section. So that's example 4. Now this says the quadratic formula comparison. Here it says we want to solve negative 5x squared plus 50x minus 3 equals 0. Now, if I were to do the quadratic equation, it would be negative. Oh, shoot. It would be negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's do that real quick. Remember, this is your a, this is your b, and this is your c. All right. So that's going to give us negative 50 plus or minus the square root of 50 squared minus 4 times negative 1 times negative 3 all over 2 times negative 5. Okay. See how quick we can simplify this. This gives us negative 50 plus or minus the square root. Now 50 squared. Oof. I think that's something. It's 2,500. Okay. Now, minus 4 times minus 5 is positive 20 times negative 3 is negative 60. All over 2 times negative 5 is negative 10. Alrighty. Okay, now we get to look at this. So 25, that's what, 2,500 minus 60, which gives us the square root of 2,440 all over negative 10. Let's see if we can figure out what that is. Use your calculator here. 2,440. Hit the square root of that. That doesn't break down nicely, does it? Let's see if we can break that down a little bit better. Trying to think of what 2,440 might break down into. Let's see. I think it breaks down into two. So I think we could probably break it down like this. Say like 4 times 610 maybe. All over that negative 10. Okay. What that would give us is negative 50 plus or minus 2 square root 610 all over negative 10. Now this next step's a little important. I'm going to divide and kind of split these terms. Negative 50 divided by negative 10 is 5. Okay. Negative into a plus or minus just turns it into a minus plus, which is the same thing as plus or minus. So I'm just going to leave the sign alone there. And 2/10 reduces to 1/5. So I'm going to write this as the square root of 610 over 5. And that would be my simplification. Now, let's just say that I wanted to compare that to doing it with the, because it does say comparison here. Let's compare that to doing it by completing the square. Okay, if I were to complete the square on this one, I would pull out the negative 5. It would leave me with an x squared and then a minus 10x right there. And then, of course, you've got the minus 3 equals 0. At this point, my n here is negative 10. So I need to look at n squared over 4. So I'm looking at negative 10 squared over 4. 10 squared is 100. 100 divided by 4 is 25. Okay, that means that this needs to look like negative 5 times x squared minus 10x plus 25 minus 25 minus 3 equals 0, right? Which looks like negative 5 times x minus 5. If I factor that part, remember I'm just factoring this piece right here, should factor into x minus 5 squared minus 25 minus 3 equals 0. Okay, and then we can distribute accordingly. So it's going to give us negative 5 times x minus 5 squared. And then negative 5 times negative 25 is going to give us positive 25 times 5 is 125. Minus 3 equals 0. Okay. Now this gives us negative 5 times x minus 5 squared. 25 minus 125, sorry, minus 3 should give us 123. No, 122 equals 0. Sure. Okay. Now, here's what we're going to do next. We are going to subtract the 122 over, so it gives us negative 5 times x minus 5 squared equals negative 122. I'm going to divide by negative 5 so that I'll be looking at x minus 5 squared equals 122 over 5. Okay. Now, I'm running out of space and I don't think I put me an extra slide on here. So I'm going to clear this slide. Let's see how I do that. Okay. I'm going to clear that slide so I can go back. At this point, I've got x minus 5 squared equals 122 over 5. That's what I'm trying to solve, right? So I can take the square root of both sides. It's going to give me x minus 5 equals plus or minus the square root of 122 over 5, which means that x equals 5 plus or minus the square root of 122 over 5. And you're like, that's not the same thing, Mr. Shipes, because the same thing is supposed to be 5 plus or minus the square root of a 610 over 5. Well, the difference here is they rationalize that denominator. If you were to go through here and do that, you'd be looking at 5 plus or minus. You basically multiplying this last piece here by the square root of 5 over the square root of 5, so that it would be the square root of 122 times the square root of 5 all over 5. 122 times 5, you can double check me, but it should be 610. Indeed. So that if we rationalize the denominator, it indeed does look like the same thing that we would get if we used the quadratic equation. Okay, because there's the quadratic equation, 5 plus or minus the square root of 610 over 5, 5 plus or minus the square root of 610 over 5. All right, so either way you do it, you'll get the same answer. You might prefer to do it with the quadratic equation, that's fine. You might prefer the completing the square method, that's fine. As long as you're getting the right answer, I'm happy that you were able to complete it correctly. If you have any questions, let me know. Give the homework a try, and I will see y'all next time.